Hello, everyone. I hope you're doing well. Thank you for joining the Fugue Cloud Security Masterclass, where we're all about putting engineers in command of cloud security. I'm Drew Wright, co-founder here at Fugue. If you've attended a previous Cloud Security Masterclass session, thank you, and we appreciate you returning. And if this is your first time, welcome. We're thrilled to have you. And if you've seen my colleague, Josh Stella, run one of his live cloud misconfigure exploits before, we think you're gonna really love this session. I know I will. These are my absolute favorite topics that Josh tackles. But before Josh gets started, let's do some housekeeping. First, we have a growing library of masterclass content available on demand for you to access at any time. That's at fugue.co/masterclass. Please do check that out. And we've got one coming up at the end of the month that is focused on security and serverless. It'll be a lot of fun. And also make sure you sign up for updates at that URL because we'll be announcing also a virtual event coming up that's focused on cloud infrastructure security and kind of from the engineer's perspective. We're pretty excited about what we're putting together. And we'll be sharing that with you shortly. It'll be better if you're there. We also just released the first edition of the Engineer's Handbook on Cloud Security. It's a reference jam-packed with useful information for you to help you get your cloud secure and keep it that way. That's at fugue.co/handbook. All right, so chat is now open. If you have any questions or comments at any time during the session, please pop those into the chat in Zoom. We want to make sure that we want this to be interactive and fun. I'll make sure that I help Josh get those questions so he can respond to them. Any conversations that we want to get going about this, we want to hear from you. And with that, why don't I turn it over to Josh? Hey, Josh, you there?
Hey, Drew, I am here. Are you hearing me okay?
Loud and clear.
Cool. All right. Well, thanks everyone for attending. We're going to be doing a few things today. So a little bit about the Masterclass series. So what we're trying to do with this series of classes that we're offering is get you thinking in a way that allows you to master a topic over time. All right, so we are going to dive in today on 4 hacks, real world hacks, and talk about the details of those. But the title says it all. This is about, we've got the wrong title on this slide, but this is about thinking like a hacker. So first, why should we be? 2, we're going to do a deep dive on it. And Q&A, we will have some time at the end for it, but also it's throughout. So anytime you want, ask a question. So why is it important to think like a hacker? We're focused here mostly on cloud misconfigurations, although I will actually touch on a lot of topics related to hacking and the mentality and motivations and techniques of hackers, whether or not we're talking about cloud breaches. I mentioned I'm going to cover 4. 3 of them are cloud breaches, and one of them is not, because I want you to think like that kind of hacker. So we're going to be talking about the different kinds of hackers, what their mentality is, what their motivations are, what their resources are, and how they can exploit you, and therefore somewhat how you can protect yourself. How you can protect yourself is a vast topic, and we'll cover some of that today. I'll highlight ways you could protect yourself from these individual breaches. Most are kind of referred to in this slide, right? Most of these breaches are due to cloud misconfiguration. However, it is a nearly infinite topic. How do you defend against hackers? So we can spell out some ways, but mainly the point today is if folks leave this class excited about thinking like a hacker, excited about imagining doing these things themselves. And by the way, I'm not a hacker. The 90s don't count, but I'm not a hacker. Most of my background is in national security kinds of applications. I worked at AWS, focused on national security. Drew and I founded Fugue. a number of years ago to provide better security to folks. But it's really important, and by the way, a whole lot of fun, to really put the black hat on, even theoretically, and think through some problems and think how you would attack it. So the goal here is to get you thinking like a hacker, to get you analyzing what you see in the news, and we're going to use real stories from the news today, to put yourself in their shoes to better understand your own security posture. Okay, so a little bit about cloud misconfigurations, because in all but one of these hacks, it's cloud misconfiguration that's ultimately the problem. It may not be the foot in the door, but it is the way that the hacker exploits the target. And the reason for that is that cloud misconfigurations are devastating from a security posture perspective. So hackers want to find the way to get to your cloud misconfigurations, even if they've done something like penetrate an operating system on a single compute instance. That honestly doesn't do much these days. So they're trying to get to that next level, and that next level is defined typically by cloud misconfigurations and mistakes. They're mostly not considered compliance violations, or many times are not considered compliance violations, because a lot of the compliance regimes that we work under are kind of pre-cloud and catching up still. So the security teams aren't really cued into them, and therefore they're commonplace, and therefore hackers exploit them. So a little more about the Masterclass series. You know, we're now in month 8,927 of COVID, by my reckoning, and there are no more trade shows and no more swag. So, and those were fun. So one thing we do in these classes is we take little breaks midway through, you know, a few times we'll take breaks, and I'm going to put up a background behind me on Zoom of something that I think is cool, which means it's probably pretty darn geeky. So it'll be like movies, video games, and you know, the computing, history of computing. And the first person in the chat who announces to public, you got to chat this to public, what the computer is if I show a computer, what the video game screenshot came from if it's a video game, what the movie came from, you're going to win some swag. Civia is going to get your details and send you some cool stuff. Okay, so I'm going to stop for a sec, and we'll do the first one of those now, because we want to start off having a little bit of fun. All right, I'm going to stop my screen share, and I'm going to select a background here. So I'm narrating this so that you're less bored while I'm doing it, hopefully. Okay, and there we go. Are you seeing my background, folks? Sylvia, Drew, oh, wow. Well, obviously, yes, because Dan Bicker nailed it immediately. Okay, I thought I was being a little tougher on it. So the theme of my backgrounds today is related to thinking like a hacker. This is an Enigma machine. If you're not familiar, the Enigma machines were some of the, I won't say earliest, but fairly early World War II era the cryptographic devices that allowed the Germans, the Nazis, to send orders to submarines without them being understood by the Allies. And of course, Alan Turing and a whole bunch of amazing, brilliant men and a lot of women at Bletchley Park cracked their code using an early electronic computer. All right, I'll turn my background off and we'll get back to the rest of this session. So nicely done, Dan Bicker. Okay, let's go back to sharing my screen. So today's class is going to be a little bit of an experiment. I was trying to figure out how to get you thinking like a hacker. And I thought about, you know, very, very narrow scenarios, but I thought, you know, when I do this and I, with our team here, kind of reconstruct a lot of hacks. When we see them in the news, that's kind of our job at Fugue, is to protect you from what the hackers are doing. So we have to analyze what the hackers are doing. So I'm going to use real world scenarios here, and I'm mostly going to use like web pages, a little bit of AWS console, and a fair amount of whiteboarding and conversation. Before we get into the specific hacks, though, I want to talk about, and I'll pull my whiteboard up here. I want to talk about how hackers operate. And there are a number of dimensions to this. There are different ways you can kind of take it apart. But the way I think of it is, one, hackers have motivations, right? Every time I use Zoom, my whiteboard gets slow. I'm going to have to complain to Zoom. So what are some motivations? Throw them in the chat. What do you think hackers are motivated by? Oh, and I lost my chat. Hold on, I'll pull it back up. Zoom is so handy for this. Yeah, money and fame. Yes, Amir says money, fame, and ranking. Interesting. So I would say number one is probably money, with some categories of hackers being less concerned with that. All right, Carl says data. I think money, and I think data is a means to an end. I'm going to say fame, recognition. Wow. Why are you doing this to me now? Okay, thank you. Revenge. I'll add that. I didn't think of that one. Revenge. Actually, that works pretty well with the other one that I had, which is politics. Right, or having an agenda. So most hackers breaking government institutions, somebody lolled at politics. Hey, one of the hacks I'm going to show is 100% about geopolitics and international relations. And it's one of the more interesting ones. They're rare, but it's kind of worth thinking about, right? Yeah, we had state actors, ideology. Yeah, these are good answers. So in terms of motivation, we can identify different motivations. So putting on your hacker hat, Akif says IP, to be first to develop. I assume that means, I think that means like stealing intellectual property. Yeah, that I would say ultimately is some combination of money and fame or recognition. But what's important to understand is that the hacker is motivated by something specific. It might be they want to put money in their bank account. It might be that they are part of a larger organization, and really there are, probably at least a couple kinds of organizations beyond the individual. So, and I put those things under the idea of resources. So if you're an individual, your resources are going to be your own skills. And if I'm a clever individual, I'm going to take your resources over and use them for me, right? But there are collectives now of hackers. They are typically, organized kind of informally or sometimes formally into groups. So we'll call those hacking groups. Very often, or hacking collectives. Very often, these are actually how state sponsors do their dirty work, rather than having their intelligence agency directly do something, particularly in places like Russia and China, more Russia than China. You'll find these hacking collectives are kind of semi-public, but there are hacking collectives that are just organized crime, right? But they have more resources. They have more things to bring to bear. And then obviously there are also, state actors and large organized criminal enterprises. Those are kind of unusual compared to the other two. All right, I'm just checking the chat here. So, so what we're going to do today Well, let's next talk about the techniques they use. Okay, so we need to establish, if we want to think like a hacker, we have to think about motivation. We have to understand what resources we have. And then we have to employ techniques. Okay, and the very first technique, I'll just put this down here as 3, and hopefully I'll write slower so my computer can keep up. The very first thing I need to do as a hacker is discover. I need to find things that I can exploit. That might be a misconfigured cloud resource. That might be the email address of an executive that I can spearfish. That might be a contractor who is working on a large project and carrying a laptop in. But I need to find out how to get my foot in the door, and that's about discovery. Now, we're going to focus more on cloud than not on cloud, and I'm going to talk to, as we go through this, I'm going to talk to the ways that hackers in real life have discovered the cloud resources and misconfigurations and vulnerabilities of their targets. Okay, I'm going to go less into some of the other techniques, all right? They're going to do discovery. They're going to get insertion. So they're going to try to insert, get on a machine, flip somebody's account, get some user credentials, and then they're going to exploit, right? So what does exploit mean? It varies. Everyone thinks about data theft. You should be thinking about data theft. That is a common means to the end of getting money, for example, or revenge or politics. But other kinds of exploits happen too. Stealing your bank account to do, crypto mining within your infrastructure is very, very common. So there are different kinds of exploit. All right. Should I jump to the specifics here? We're digging a little more. Oh, finally, I talked about stealing data and stealing compute for things like mining cryptocurrency, which is really a common thing to do. Another type of exploit is to change the behavior of the system. This is less common, actually, than the other two. But an example would be, I worked years ago, I won't name names, at a place where one of the, it wasn't my responsibility, but one of the web presences, one of the websites was defaced by hackers in order to carry out a political agenda. Well, that's modifying behavior, okay? So they're gonna discover first, and so you need to worry about defending against that discovery, because that's critical path for hackers. Then they're going to find a foothold, they're going to do insertion, and then they're going to do exploitation. The exploitation in cloud is almost always through cloud configuration of resources. And the reason is the blast radius is just much greater than getting root on an individual Linux box in a distributed application. Who cares that much about that if it's not a means to an end? All right, I'm going to check the chat here. Right. So let's drill in. I'm checking time. In a few minutes, I'm going to do another background. But let's drill into some hacks. All right, and by the way, I'm using real hacks that really happened. So names are named. There, but for the grace of God, go all of us. I don't mean that in a religious context. I'm just using the saying, right? Like, this could happen to any of us. These are not organizations that are unsophisticated. These are not organizations that are to be mocked or overly criticized. You probably have vulnerabilities in your infrastructure that can be exploited. You almost certainly do. So when I bring these up, it's not to put these organizations down. I actually know people at most of these organizations who are brilliant engineers. It's to illustrate what really happens, because the theme here again is thinking like a hacker. Okay, with that caveat, I'm going to go to the first example I have, and I'm actually going to use two examples because it's the same hack. And there's actually a pretty theoretically easy solution to this. So we know that Uber has been hacked at least twice in their cloud. And both hacks appear to have been done the same way. And this, by the way, is an extremely common way for hackers to get access to your stuff. So I've highlighted a paragraph here on my screen from a Bloomberg article, which I will read to you. Here's how the hack went down. 2 attackers accessed a private GitHub coding site. Okay, let's pause. Private GitHub coding site means somebody got credentials to GitHub. A hacker got credentials to GitHub to see the private data in GitHub. So this should tell you 2 things. First, hackers are going to chain together a path to getting to the exploit they want to do. It's not about one error, it's about a series of errors, okay? So, and you'll see that over and again. This one's actually very simple compared to some of the ones I'll talk about later. But when you're thinking like a hacker, if you've ever played Dungeons and Dragons, you're going down levels, okay? You're exploring the maze. And so it's not that you find one thing that's the key. It's that you're finding a connection of things you can string together into something that is truly beneficial to your motivation. In this case, money, right? So 2 attackers accessed a private GitHub coding site used by Uber software engineers and then used login credentials they obtained there. Right, I'm pausing dramatically on purpose to access data stored on an Amazon Web Services account, ... Don't ever, ever, ever put credentials in source code or a config file that goes along with source code. This was a private GitHub repo. This was not public on the internet, okay? This was a private GitHub repo. Yet, a hacker, all they needed to do was find a way into the GitHub repo, and then they had AWS credentials. So don't do that. And in fact, check to make sure, and I'm going to show you, oh, Zoom, get out of my way. I'm going to show you a project called Get Secrets from the good folks at AWS Labs. And what this thing will do is it will check your repos to see if there are AWS secrets in them. And that's a useful tool. It's not a silver bullet, because I've also seen credentials stolen from things like S3 snapshots of disks and things like that. The real message here is don't store your secrets on the disks of servers or in repos ever. Use a secrets manager of some sort. AWS has one, there's open source ones. We publish an open source one called CredStash. They're commercial ones, but just don't put them on the disk. Now you might be thinking, well, on my laptop, I have some AWS creds. That's not as bad, right? I mean, so do I, right? That's not as bad. You want to limit the blast radius of what those creds can do. But really what we're talking about here are the kinds of credentials that are used in production by production. All right, so in this case, so from there, the hackers discovered an archive of rider and driver information. Later, they emailed Uber asking for money, according to the company, back to motivation, in this case, money, pure and simple, right? To my knowledge, this data has never been published, probably because they got paid. All right, I'm going to talk about another very similar exploit alongside this one. And again, I'm not trying to cast aspersions on folks. These are real world exploits, and it's important to deal with that rather than me hand waving about some theoretical nonsense. But this can happen to any of us. So this is from a breach that happened to a company called Imperva. They make things like web application firewalls for cloud and so on. So they're security practitioners, and they're pretty darn good at it. But they got hacked too. So again, this can happen to just about anyone unless you're extraordinarily careful. So in this case, how it happened, this, by the way, is straight from their website. The other thing was a Bloomberg article about Uber, but this is straight from their website. Some key decisions made during the AWS evaluation process taken together allowed information to be exfiltrated from a database snapshot, not from a running database, okay? And this is a repeated pattern too that you'll see. These were one, created a database snapshot for testing. Two, an internal compute instance was accessible from the outside world, and it contained an API key. Do not put your credentials on your machines. Use some kind of secrets manager. Make this harder for the bad guys, and also key rotation people. So, so they got in, they, through a compute instance that was accessible from the outside, they found an API key. The compute instance got compromised, and the AWS API key was stolen, okay. And then the AWS API key was used to access the snapshot. So in the end, this is a cloud misconfiguration issue. This is getting access to that AWS API key and exploiting, stealing that snapshot out. This is not about breaking into a database. They didn't break into the database. And you'll see this theme over and again. So back to thinking like a hacker. We don't fully know the motivation behind this one. I suspect it was also money. Most of them are. And by the way, a lot of the serious hackers that are kind of semi-governmental in other places in the world do both of these things at once. They are kind of self-funded by doing things like extorting folks and stealing data and so on, but they also have political motivation. So there's often an overlap there. So when you're thinking like a hacker, don't imagine that the hacker has one motivation. They often have many motivations. Somebody posted, Vahid commented, an internal job. You might know more about it than I do. I don't know if this was an internal job or not. What I do know is those AWS API keys should never have been stored on a disk that could be accessible. A secrets manager should be used. And you might say, well, if I have access to an instance, might I have access to its secrets? In many cases, yes, you do. And that's why key rotation becomes important, so that those credentials aren't useful in the longer term. So let's take a look at their corrective actions. So, okay, number one, applying tighter security access controls. Okay, fine. Two, increasing audit of snapshot access. All right, audit is okay, but it's after the fact. What you want to do is prevent misconfigurations to snapshot access. The problem with data theft on cloud is it's so brutally fast when it happens that in learning about it after the fact, it's not like they're doing slow motion data exfiltration by, shoving packets into DNS requests or something like in the old days. They're just taking the whole snapshot. So by the time you hear about it, that might give you advance warning that you're going to get fired, because all the data is gone. So things like audit, you have to do them, it's worth doing, but you really, really need to be preventative. And that's where cloud misconfigurations are critically important. Akif, I hope I pronounced your name right, asked the question, were snapshots not encrypted? I don't know the answer to that. I don't know. And this gets into an interesting point, which is when you're configuring cloud, you of course want to encrypt everything, but you want to encrypt it with keys you're managing, not necessarily keys the cloud service provider are managing. Because in many cases, like with anything in S3, if you're just using server-side encryption, if you have access to the S3 API endpoint to do a GET command, it's going to be decrypted automatically for that attacker without them needing credentials to get to keys in, say, KNS. So I don't know the answer here. Okay, decommissioning inactive compute instances was the third corrective action. Please do this. So many of these attacks are done by exploiting forgotten kind of zombie resources in the cloud. It's one of the things at Fugue we focus on a lot, is helping you find those and get rid of them, because if you're not patching your OSs, if you have CVEs out there in your compute infrastructure, and a lot of our customers have thousands or even more, tens of thousands of compute instances, it can be easy to lose track. Well, the bad guy doesn't care too much about getting into that instance, but they do care about getting the API key once they get into that instance. So you got to get rid of the old orphaned infrastructure. Rotating credentials and strengthening our credential management process. Yeah, of course you should have a strong credential management process. Rotating credentials is a big deal here, because a lot of times I'll read about these hacks and keys will still work like years or months or years later. That's crazy. You should be using things like IAM credentials and, again, rotating keys. That's critically important. All right. Yeah, I won't read through all of these, but you kind of get the point, I hope, that these two hacks, the Uber hack and the Imperva hack, were both bad guys getting to your to their credentials, their AWS credentials, and then those credentials being valid maybe longer than they should be. So these are actually very simple exploits. These are very common and simple exploits. It can be very difficult to get your hands around preventing these because where is anyone putting any AWS credential in any system in your company? This has an educational aspect, but you can also use tools like Fugue, for example, to help you solve for finding where there's orphaned infrastructure or you're not doing key rotation and things like that. All right, I'm going to pause for a sec. We're a little over half an hour in, and I'm going to stop my video and I'm going to stop my share, and I'm going to grab another background. And while I'm doing that, I see we've got a comment. All right, I'm going to, that Enigma you guys got like instantly. So I'm going to get more esoteric, more difficult here on my background. So we're going to start the video again. All right, I got to move to the side here. This is from a video game. Name that video game. And it's very much on, it is not Star Fox, but it's a pretty good guess. It's very much on the theme of the talk today, which is thinking like a hacker. So a couple of comments while I've got the background up. Vahid says he believes scientists have found a way for encryption without needs for keys. I'm not sure exactly what you're referring to there. There are different encryption schemes that don't use shared keys. I'm not sure which one you're referring to. All right, what else? One would have thought, this is from Amir, he says, one would have thought that system admins should be running AWS compliance cloud security checks on their instances, not ignoring them. Actually, what I've just showed you probably wouldn't have been caught by anything AWS has. Just probably wouldn't have. We catch some of this stuff. This is what we do for a living. But yeah, it's not, unfortunately, it's not that simple. All right, I'm going to drill into another breach. And this is one I've talked about a lot before in the past, and I've done a deep dive and an actual recreation of what we understand about it. I'm bringing it up today because we have by far the greatest detail of what the hacker was thinking, and this is about thinking like a hacker, in this breach. So, and we also have filings from the Department of Justice. This is the Capital One breach. The Capital One breach is interesting for a number of reasons. Let me start by saying Capital One are about as good at cloud security as anyone I've ever seen. They are really, really good at it. So again, I'm not in any way saying that these are things that are foolish mistakes. They're not foolish mistakes. It is not Final Fantasy. I feel like my background's too hard. Oh, Tony Snyder nailed it. I wonder, Tony, I hope you didn't Google image search this. But Tony got it. It's from a game called .hack, which was, I believe, early aughts. I want to say early 2000s, and it was a Japanese role-playing game on the PlayStation 2, and was just super, super cool. And a lot of game designers of games you have probably played and love were huge .hack fans. So congrats to Tony. That is going way back in the archive. All right, so back to the Capital One breach and why I'm talking about it. One, Capital One's very good at this. Two, the hacker had multiple motivations and did multiple kinds of exploitation all at the same time in the same hack. And three, we've got a lot of evidence, right? We have a lot of details on how this really happened because the hacker posted on social media what she was doing along the way and why. So let's take first a look at, and I try to stick to real evidence. The news is kind of really bad at reporting details of hacks. So if you want to understand how these things really happen, don't trust the news sites, okay? You can get a little bit of evidence there, but really you need to get deeper into the evidence. So what happened in this hack is somebody tipped Capital One off. This is the actual DOJ complaint against the hacker, well, the accused hacker. I don't think convicted yet. So let's look at this section right here. So Capital One determined that the April 21 file that was found on GitHub, by the way, that file had data that was stolen in it, contained code for 3 commands, as well as a list of more than 700 folders or buckets of data. So usually when companies get hacked, that stuff gets kind of buried exactly how it happened. But this is interesting. 3 commands, specifically 3 commands. All right, the Capital One determined that the first command, when executed, obtained security credentials. I think this means AWS Cloud credentials for an account known as something WAF role that in turn enabled access to certain of Capital One's folders, S3 buckets. The second command, so first breach is getting in through a workload exploit, something running on an individual server. Nobody really cares too much about that. The hacker doesn't care too much about that. They're trying to get the cloud credentials. They don't care if they can root the server, it doesn't mean anything. We're building distributed systems. They're trying to get to data to steal money, ultimately. So, well, actually, in this case, it was more recognition and notoriety, but she also stole money another way that I'll explain that really hasn't been put in the news too much, but we know that it happened. So then did a list buckets. We're back to discovery. The hacker in this case wants to get access to that cloud infrastructure in order to discover other cloud infrastructure in order to steal data and do other things, okay? So list commands, and I've said this over and again, and I think every masterclass we've taught, list commands are super dangerous in your environments. Your applications should never use them. If your application is using it, a hacker can use it. Now you need list commands to do administrative work, that's okay. But you need to make sure that individual instance can't do list commands. So Amir says service was running with a higher privilege, otherwise one would not be able to carry it out. Not exactly true. So you're close. Well, yeah, I mean, sure. But there was no like admin privileges on that instance, right? What was on that instance, and I'll show you here, where is it? Yeah, here. So this is some of the hacker's actual social media postings, right? I hacked their EC2 instances, assume role on their IAM instance profiles, take over the account. So you didn't need to have full high privileged IAM access. You just needed the EC2 IAM privilege to assign a different level of access to that EC2 instance, take over their account, corrupt SSM, deploy backdoor, mirror the S3 buckets. That is the next command listed here in the Justice filing, Department of Justice filing, is the sync command, which is reliant on S3 list and also obviously on things like get object. I always prepare a whole lot of information for these and maybe won't get to quite all of it. So the point here is that the hacker is, again, chaining together things that they can exploit in order to get to what they want. So here we've got S3, mirror the S3 buckets, convert any snapshots I want to volumes. Okay, so snapshots can be converted to volumes, and mirror the volumes I want via storage gateway. And I'm curious if anyone has a theory about, look, we don't know that all these things were exactly done. This is what the hacker was posting to social media, bragging. So maybe some of it's BS. I don't really know. But this is what she said. And I found that mirror the volumes via storage gateway quite interesting. I have a theory of why I might do that as a hacker, but I wonder if anyone else has a theory about why they might do that as a hacker versus a simpler mechanism rather than standing up new services. We know more about the Capital One breach though. So this is about the data theft, but let's look at the press release from the Western District of Washington from the United States Attorney's Office. Here we get a little more, okay? Here we add to that, according to the indictment, Thompson created scanning software that allowed her to identify customers of a cloud computing company who had misconfigured their firewalls, allowing outside commands to penetrate and access their servers. So that's interesting. If I'm a hacker, I don't want to work hard. I'm a programmer. I automate stuff. I don't sit there at a keyboard with a cup of coffee till 3 in the morning. I'm playing, video games or doing whatever. I'm going to automate this. And it says right here she did. And we have evidence that the Capital One exploit was actually not probably targeted. It was probably opportunistic. Creating a program that goes and looks for issues, scanning lots and lots of stuff on public IP. If you have a public IP, it's probably getting scanned at least once a minute for vulnerabilities in it, identifying those, and then getting up in the morning or at noon. I don't know, we're pretending to be a hacker here. If I were a professional hacker, I'd probably get up at noon and get my cup of coffee and go, oh, look, that's an interesting company to see if I can exploit. So that's the first interesting thing on this. The second one is that Thompson used this access not only to steal data, but also used stolen computer power to mine cryptocurrency for her own benefit, a practice known as cryptojacking. This is extraordinarily common, okay? So back to motivation. In this case, the hacker never sold the data, never bribed the company with the data. The only way the company ever found out about it was because somebody dropped the dime on her and said, hey, somebody's going out there in social media and on GitHub and saying your data's out there. But she never actually did anything malicious with the data, but she was running crypto miners in their infrastructure. And that is also theft. That is theft of compute. So a little brief explanation of what this is. If you're not familiar, I'm pretty sure most people are familiar with cryptocurrencies now, but they are currencies that derive value based on factoring numbers and doing other kinds of mathematics. We used to have gold-backed currency. This is kind of coal-backed currency. It is compute power applied to solving difficult mathematical problems to generate unique coins. So it's expensive to compute, okay? In fact, if you're running a standard CPU or even GPUs, and by the way, if your cloud account suddenly has a bunch of GPU type instances appearing in it, you should be looking for crypto jackers in your account because most business applications don't need GPU-based don't need GPU-based compute instance types to do their job, but it is absolutely needed for any kind of efficient crypto mining. The serious people who are doing this non-criminally are actually running custom ASICs, custom chips that are way, way, way faster and cheaper to run than GPUs for mining cryptocurrency. So long-winded way of saying, if I can steal your billfold to run my GPUs, then crypto mining can make sense for me on the cloud. And this is quite common. So again, when you're thinking like a hacker, in most cases, in almost all cases, you probably have a mix of motivations. If you can get in there, am I going to steal your data? Well, yeah. If you leave it laying around, sure. But I also might generate some Bitcoins. So often these things are the motivations are blurred, because by definition, these are usually criminal actors of one form or another. All right, I'm going to stop share. We got time for another background. I'm going to stop video, and I know we've got a couple of questions or comments that rolled in, so I'll address those. All right, we did a computer, we did a game. Let's do a movie. And keep in mind, my theme is going to be consistent today. So I got to shove myself to the side here while I look for all right, so if you know this movie, post it into the chat and you'll win some swag. And I'm going to try to go back through some of the comments. So Vahid says, well, that's just a panelist, so let me make sure. It's not Matrix. It's not Matrix. Good guesses. Matrix is a much better movie than this one. This is a terrible movie. Oh, Ryan got it. Didn't get your spelling right, but I know what you mean. This is from a terrible movie, in my opinion, from an awesome story. The movie was called, and the story are called Johnny Mnemonic. It was a William Gibson story, who is the kind of one of the fathers of cyberpunk literature, if you will, and really, really cool story, really, really questionable film. But I want to get back to some comments. I want to make sure I'm not saying anything that doesn't want to be made public. Yeah, so the gist of these two comments from Vahid are that security has to be baked into the development through the DevOps process. I completely agree with that. And that's what we do. I mean, we've built a whole product to do that. So I agree with that. And we have a bunch of other master classes. We've got more coming on how to do that. And Drew Sivia, maybe we take a note that one of the master classes might be baking security into DevOps. We've been doing things like S3 and IAM and more focused on the service types and techniques. All right, we only have a few more minutes. So yeah, so just these are a couple of more screenshots from Erratic, who was the C1 hacker. I probably don't have time to get into the details of these. If you watch our class on recreating this hack, I will go into a ton of detail on that. It's a video recording on exactly what these are and what they're about. I do want to cover one more hack because there's another way of thinking like a hacker than the simple hack to bribe somebody for money, the more complex hack from a more sophisticated individual actor or small group, like the C1 hack. And then you've got the truly scary stuff that these are true experts. And I'm pretty sure most folks have heard of Stuxxnet. Stuxxnet was a malicious worm. This is just a Wikipedia page that was infiltrated into nuclear programs in places like Iran, primarily Iran, but it made it other places as well, including back to the US, by the way. And what it would do is it would try to find machines that had access to what are called SCADA networks. I used to know what SCADA stood for. What SCADA is used for, SCADA, is things like control devices on manufacturing machines, on measurements on oil pipelines. It's a protocol that's used for controlling real world hardware, physical devices from software. So also think about power plants, right? So in this case, we're talking about uranium centrifuges. So the attack vector here is different. The motivation is different. The techniques and the resources are different. This requires a lot of resources. The three hacks I just showed you, what's the resources? It's like one person, maybe flip an insider through some social engineering, but this is, you know, the three I already showed you they don't require a lot of investment. Well, there are people who will invest a lot in doing these kind of surgical strike attacks. You're unlikely to be at the receiving end of this kind of attack. You're more likely to be on the receiving end of a retaliation from this kind of attack. But I think it's interesting, and again, my mission today is to get you thinking like a hacker. It's to make you excited about doing these kinds of things, even though you're not going to do them, but to get you thinking that way so that you can put your black hat on and look at what you're running, okay? So in this one, this is really, it took years to develop this apparently. From the best evidence we have, nobody's ever owned up to it. You know, most people think it's the US and Israel who did it. We don't really know. Possible, maybe likely. Thank you. Neil says supervisory control and data acquisition is what SCADA stands for. Thank you, Neil. So what they were doing is with a USB stick that they had to walk into a plant with, and again, if you remember at the beginning, I said maybe contractors can be leveraged in some of these kinds of hacks. In this case, probably so. And then instantiated a low, slow, essentially worm that would look for computers. It was based on Windows, but you could do the same thing on other operating systems. Looking for computers that had a certain application written by Siemens that was designed to interface to SCADA, and then they would just wobble the centrifuges. And that, you know, if it's a washing machine and, you know, you put some sneakers in it and it wobbles and goes gadunk, 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 it's not a big deal. If you wobble a very, very high RPM centrifuge running uranium, it has very, very devastating consequences to that centrifuge. And it created years of these folks trying to figure out what was going wrong with their centrifuges. Okay, so interesting about this. So I just wanted to share it with you because I think thinking like a hacker is a really fascinating topic and one you should be excited about. And if you get excited about it and you research these things, you'll be better as a security practitioner because you'll realize these folks are smart and they're creative. But the other reason I brought it up, and I don't know if I'm going to find it on the page right now. Well, yeah, you can see here it spread to other countries, even though it was a very, very targeted worm. But where is it? Was it here? Well, I'm not going to find it right now, but it's likely that the state actors, in this case, Iran primarily, but there were others, targeted Western banks as retaliation for this. So what does that tell you in terms of thinking like a hacker? It tells you if you read something in the news where there's a major event in cybersecurity that is any way connected to what you're doing as a company, even politically or indirectly, you should be on alert then. You should be concerned about retaliation because in thinking like a hacker, I'm not going to hit you symmetrically, right? If I'm the recipient of this attack, like Estonia, their entire network infrastructure was effectively taken out. Same thing happened in Georgia. by kind of semi-governmental Russian organizations. The retaliations don't tend to come back to governments. They tend to come back to lower targets, and those might be you. So the point I'm trying to make here is, one, be aware of what's going on out there. Think like a hacker. Think if you might be in the zone of fire for return fire on these things, and try to understand what the motivations are of the attacker in order to make sure you're as defended as you can be.
Wanted to step in and make an announcement. So we did have a snafu with the scheduling of this through Zoom, and some folks may be here expecting this to start at 2. I know we just got a message from William asking about that, and we will continue, stay on and run through this again, and we can kind of
get my background now.
Yeah, no, and and then obviously anybody that's on is more than welcome to stick around for round 2. There might be some different questions and some different topics that we get into. Yes, if you're here showing up at 2, you're not wrong. We were incorrect in sending that out, and we want to make sure that we deliver this this presentation to everybody that thought it was at 2 as well, and do that live.
All right, cool. Yeah, so yeah, we sent out mixed information. Some of it said 1 o'clock Eastern, some of it said 2. So for those of you who've been around since 1, we're going to start over in a couple of minutes here. What I would propose that we do is get your last questions in. I'll answer those real quick, and then at like 2:02, like 3-4 minutes from now, we'll just start from the top. Does that work, Drew?
That works. And I've got one question that I know has come up frequently. It hasn't come up in this one, but I think it's relevant. Is we know that you can get your cloud configurations secure on day 1, but they can become unsecure, and you can get misconfiguration on day 2 because our clouds are always changing, and a lot of times people have long intervals between their audits. What might be some changes to your cloud configurations that should set off alarm bells for you?
Well, there's a fairly long list. Some of the ones that come top of mind, and by the way, the Fugue product catches these, and we have a forever free developer version that will help you with this stuff. Top of mind are things like change in IAM role profile association. So if you've got a compute instance running under one IAM role, and by which I mean that compute instance has a set of permissions defined in IAM, and it changes the role association or the profile, the policy, that is usually something you really, really need to look at. Because if that happened, it could literally be almost anything if that was initiated from that EC2 instance. That's one example. In the case of things like, one, and we do this in Fugue, you want to check for things like list and describe command permissions on stuff running in the production infrastructure up front. So that's getting it right day one, is don't allow that stuff. So if you have an application that relies on S3 list, for example, don't do that. Put it in a database, make a separate call with different credentials. But if you see permissions being granted to things in the infrastructure for those list, describe, et cetera commands, be very aware of that, because the hardest job, honestly, for the hacker is usually discovery, is usually figuring stuff out. So people are always worried about data theft. By the time you're worried about data theft, it's already been stolen, right? You need to worry about them finding your data.